All right, hi everybody. So we're still going with this series. I actually recorded a whole conclusion, and I just kind of decided while I was on vacation for a little bit that we really haven't finished. There's still things we can do to make the software overall better, so we're gonna do that. The first thing we're gonna do is we're gonna take this, and we're gonna stop doing all of this like bit operations because we don't actually need to do it because we're not doing like a kind of like dynamic allocation thing anymore, right? We're just setting it. And so that means we can use something called an std bitset. So we're going to use that. And then what we're going to do is in the next video we're going to get rid of our linked list, this pooled linked list that we spent so much time on. Because since we're not like making it bigger and bigger and bigger, we have like a set size to guarantee that it doesn't get too big. That really means we should just be using a ring buffer. So we'll make it so it's like a size 1,000. So it really shouldn't ever come up, but we'll just allocate a bunch of memory and then on the stack. And then we just won't really care about it anymore in the program's execution. So those are the next 1 to 3 or 2 to 3 videos. And then we'll get to the conclusion. By that time, I'll have more levels. Like these are just empty levels. I've already started creating some like actual levels, but in one of the videos we'll go through some of the levels. Maybe we'll actually just do like a fun little playthrough of the final 30 levels that I make. I'm not actually going to record me making those levels because I don't think there's a lot of fun there. But yeah, so in this one we're going to just get rid of these, move to a bit set. So yeah, let's get to it. All right, so this is a bit set, and we're just on like cppreference.com. And basically what it's doing is it's just doing the work that we were doing for us. And all we really need to do is reset, so set the bits to false. We can set a given bit to false. So in this case, you can see, like you can say set I and make it to false. If we just want to make it all ones, I believe we just do this. If we want to make it all zeros, we just do this. We can always flip, so this is like an or an XOR maybe. And yeah, so we're just going to be using an std : bitset, and we're just going to get rid of all this. So we do this, now we can do this, bit set, right? And then what we need to replace it with is level max width times level max height divided by 8, right? And then what we can do is we can just get rid of these. If I knew my vim commands a little bit better, I could have done like all those at once at the end there, but that is okay. So we have this. This is a little gross to look at, so let's add a space. There we go. All good there. Divide by 8 because, and then we actually don't need this divide by 8 anymore because it's a bit set. It's doing it for us. So this is level max height. That looks good to me. And then we could even like, just to simplify this code a lot, we could do like const std : size t bitset size is equal to level max width times level max height. And then we could just level max. I'm a little confused why I did. Oh, there it is. Bitset size. Is that allowed? Oh, and then this is just missing this. I guess they're saying it has to be like, if I did like this. Yeah, okay, we'll just keep this as this. That is okay with me. Okay, so now what we're going to do is we're just going to be getting rid of all these because we don't actually need it anymore. And we're going to keep Sokoban index though, because we still need that. Get rid of bit operations. So now we can go into here, cdsrc, rm, bit operations, back, make it. Oh yeah, I was also going to add a submodule. We'll talk about what a submodule is in a little bit, but just so you can see what I'm talking about is I already started it for another game that I'm not videotaping me making as I go. But like you can see I have like, for example, our pooled linked list already in here. Okay, so let's go into Sokoban, C++, And you can see we're doing all of this. And we're doing this to allocate memory and then set it to 0. Well, we already allocated, sorry. We're doing it to basically set everything to 0. So in this case, it's state.original blocks dot reset. This, as you recall, reset, let's go to here, set bits to false. And you can see we can pass it an argument, or we can not set it at all. So we can set all the bits, or we can set it to a position. So this is 1 and this is 2. So in this case, we're using this to set all bits to false or to 0. So state.blocks.reset, state.solids.reset, state.switches.reset. Pretty easy there. Delete that. And now what we can do is we can actually start using this. So state.solids, right, .set, and then we just give it the Sokoban index state p. And we're going to actually be using this a decent bit, so I'm just going to yank that. I already lost my yank, unfortunately, so I need to figure out a better way to delete. Let me just keep going. State.blocks, and then we got set Sokoban index state p. This easy enough. Now we go to set switches, state.switches, right? .set, nothing crazy here. Sokoban index state p. Now we can do the blocks because this is a capital, if you remember. So we do state.blocks.set. And then we can just do, I'm almost tempted just to, yeah, whatever. It's a little bit more, I think basically what I'm thinking about is just putting this at the top. But technically we don't always need to do it. So it's kind of better just to only do it when we absolutely need to do it. We only need to calculate the index when we absolutely need to. Alternatively, if we're just doing a plus plus every time, which we kind of are, all right, we'll come back to that. Is equal to Sokoban index state p state set index. Now we do state.switches.set. Now we do the index plus p.x. Absolutely. Now, we don't care about this, but we do care about the fact that we have, yeah, I don't mind what I'm confused about is, I think they're saying that I need to wrap this. Yeah. So anyways, this is that, this is that, this is that. Now if we make it, it should be a little bit better, but it's still not done yet. So we'll just go into game.cpp real quick, 157. So now instead of this, right, we can do else if app state, game state, and then dot solids, Sokoban, and then we do dot get, I think. No, we just do this. Oops. And then we can pass it the index based on p, Sokoban index, app state, game state, and then we can pass it p, and that's that, that's that. And now we just need to fix, that's fine. Where am I messing up here? Else if, close that, I close that. It is a little long, but that's okay. But we can actually just like, make this a little bit better because we're not actually going to change Sokoban. Game is equal to app state game state, right? And that makes this whole thing a little bit easier. Now we do this. And so we also found the problem when we simplified the code a little bit. It looks like we didn't. Boom, boom. So let's just do this. It may just be that. Game.solids, Sokoban index, game p. Cool, so we fixed that. Now we can also fix these ones, right? So const bool is block, and then that's equal to game blocks. And we also have this index that we're using. We're calculating this index a couple times, so we can actually just keep the index. Again, I think we can just make this like a plus plus, but I'm not remembering exactly everything right now. And so I'm just gonna leave a comment to do, and then we'll come back to it. So index is equal to Sokoban index game p this, and then what we can do is we can comment those out, and then we can get rid of this. So now our code's even a little bit better, or easier to read, let's say. Const bool is switch game.switches index there, delete this, go there. Looks a little bit better. Let's add our to do. At to do, can I just plus an index? And let's actually see how many to dos I have. Just those two that we just made. Okay, so that looks good. Now if we make it, let's see where we're at. Cool, so we're still going Sokoban CPP. We can just follow these red marks right here. So we have our memory compare. So game over, right? Really all we care about is return state.switches equals state.blocks. And I don't know about you, but I think this is a lot easier to read. Same for here, Sokoban restart, right? Instead of doing this like memcpy stuff, we can just do state.blocks is equal to state.originalBlocks. And so now we're just letting like the internal bitset thing handle this. So all of a sudden this is a lot easier to read, I think. Now we get to here, so we have our player pause. So let's go to here, const std : size t player index is equal to, and also let's change const Sokoban. It's not going to be a const actually. Sokoban reference. Why did let me go to the render real quick. Game.hpp, no, game.cpp. Did I do a copy by value here? Yeah. We want to do a reference here because we don't need to copy anything. Cool. Now we're back here. Sokoban state or game is equal to state dot app state, or what is, oh no, we already, it's just state, sorry. Okay. So player index is equal to Sokoban index, and then we can give it the state, and then we can do the player pause. Okay, so instead of this, right, we can do this, and it can be Sokoban state, what was it again? What were we checking? Solid. State.solids, and this is just the player index. Now we can check, this is state.isBlock, right? State is block, state.blocks, player index. Now we're here, and we have our block pause. So let's also get the const std : size t block index, which is Sokoban index, block pause. No, this is just state, sorry. And then we did the block pause, and then there it is. Now we can do this. So we're gonna do Sokoban state.blocks block index, and now we're gonna do is solid instead. Sokoban, I keep saying Sokoban like that's right, block index. And if so, right, so we do Sokoban dot, I keep doing that, state blocks, block index, dots, and then we do, oh no, it's just dot set block index. There you go. Block index. And then we do, this is clear block, so state.blocks.reset player index. And there we go, there's that. One more to do. So we're setting and then we're clearing. So we're gonna get the index first. Are we gonna get the index? So let's see. State.blocks, simple enough. Reset, or no, we're doing set. And then it's Sokoban index, state, original player position there. And then what we're gonna do is Sokoban, and then we're doing blocks dot reset. Let me take this, exit, let's do this. This is a little bit long for my taste, so we'll do this, this, and then what we need to do is change this to this, this to this, and then we need the index, Sokoban index, and it's going to be state. Then we do this, there, there, and I got that. Sokoban blocks reset, and this shouldn't be this, it should be this, which means this should be this. Oops, wrong direction, that should be that. That looks fine, so we probably have more errors. Let's take a look real quick. One more, it looks like. So are we in Sokoban? Yeah, 114. Did a colon instead of a semicolon. I'm sure someone noticed that and was bothered by it. Apologies. So now if we run it, let's see if it works. So far so good. Undoing's working. Let's do this. If I restart it, it doesn't work, so we'll come back to that in a second. Are all these levels just the same? But this level is different. Let's see if winning works on that one. So restarting doesn't work, so let's fix that real quick. State.blocks is equal to original player, player is equal to that. So let's look at restart in game to see if that's being called. Okay. Oh, I'm calling on enter here, so yeah, that's silly. So let's just yoink that. We want, oh yeah, I want here. Let's make it, and I think this is just gonna work, and then we're gonna be good. So let's do this. Restarting works, but we lose our blocks. Okay, so at least we have a different kind of bug now. So state block blocks is equal to original blocks. Didn't work. This is a little gross to look at. Let's fix that. So let's go to blocks, and you can see right here the problem is we're not actually setting the original blocks. So state.originalBlocks is equal to state.blocks. Copy it over. Whether or not that's the right thing to do, because I don't actually know how like the internals of like this equal signs works. What I'm hoping for is it's like literally like this kind of thing. I is equal to 0, I less than, sorry, I almost just wrote some Python there. This isn't obviously right, but I hope it's just like something like this, dots, and then you would need to like I is equal to state.blocks I. I hope it's something like this where it's just like O of n and it's just going through it super fast, but I have no idea. So anyways, we're going to keep it like that just for cleanliness. If we wanted to be more precise in like knowing exactly how this is going to do it, what we can do instead is we can go over here and we can do state.originalBlocks.set index. And then we can do it over here to state.originalBlocks, and then we would do this, do that, take this, size t, index is equal to this, set index, index. All right, so we're setting. That looks good to me. Let's make it, see if everything's working again. And that also means, fun fact, I did a whole conclusion when there was a bug. So, and now resetting is working. This is working, undoing is working. And yeah, so everything's working. So next video, we're going to implement a ring buffer. A ring buffer is just an array where instead of it always starting from index 0, it can kind of like start from the middle and go around. And that's how basically what we're going to do is handle like overriding. So that way we, instead of having like a linked list that kind of like shifts as you go along, if you create more and more commands, we're going to have a ring buffer, which is just using the same contiguous block of memory and just kind of like shifting around. And so yeah, that'll be the next video. Then we'll get to the conclusion after the ring buffer is implemented. And I think everything will be good after that. So yeah, I hope you enjoyed this one, and I'll see you in the next one. Bye.